For these examples, we'll use the quotient rule of exponents. So first, just a reminder of the quotient rule of exponents, that if you had a to the m over a to the n, that's equal to a to the m minus n. You can remember that rule, and it is true, obviously, but I always think of it as canceling common factors of whatever the base is of the exponents on top and bottom. So let's actually look at the second example first. If we had x to the ninth times x to the ninth times y to the fourth over x to the fifth y, we look at this one and look at the x's. Well, we have 9 x's on top, 5 on the bottom, so 5 of the x's cancel, and we'd still have 4 left on top. And then for the y to the fourth over y, remember that's saying y to the first. So we have y's on top and bottom. We have 4 on the top, 1 on the bottom. So that 1 on the bottom will cancel, and we'd still have 3 on the top. So we'd have left over x to the fourth y cubed. Again, you can think of that as x to the 9 minus 5 times y to the 4 minus 1. Now for the second, or actually the first example, it would be the same thing. Let's see. Let's look at the variable pieces first. We have 4m to the fourth n cubed over 6m squared n to the ninth. Well, with the m's, you have 4m's on top, 2m's on the bottom. So 2 of the m's cancel, and you would still have 2m's left over on the top. And for that n cubed over n to the ninth, well, 3 of the n's cancel. So we'd still have 6 n's left over on the bottom. So that'd be n to the 6 on the denominator. And for the 4 and the 6, we think those have a common factor of 2. So we'd still have the factor of 2 left over on the top and the factor of 3 on the bottom. So this would be 2m squared over 3 n to the 6.